What is going on, everybody? Mr. Trummer here to talk to you today about linear transformations. So, we've been working with linear equations. We know that those are just lines on a graph, but this word transformations is the new piece here. So, transformations, think about what that means to you. Some of you guys might think about the old school show of Transformers. That's what I think of. And when you think about the show Transformers, well, we've got like cars that turn into robots and robots that turn into jet planes. Basically, there's a change that is happening. That's the same case here when it comes to transformations of our linear equations. So I'm going to show you a series of different transformations, but it all starts with what we call the parent function. The parent function, if you look in this column right over here, is y equals x. And it's showing you on this graph y equals x. That's what this black line is here. And that's going to stay on here the whole time. Now, we're going to see what happens when we do a couple of different things to that parent function. So the first one is here, this y equals x plus 5. You've learned that that plus 5 is actually the y-intercept. So think in your head, what happens when we add 5 to that original x? Well, let's take a look at what it looks like. Boom. What is going on here is that we are shifting up. So think of it now. We've got our y-intercept for our parent function right here at 0. We are taking that and we're shifting the whole line up to that y-intercept of 5. The line itself, you'll see, has the same slope. The line doesn't look any different. It just moves up, or shifts up is the terminology that you're going to get comfortable with. So what happens then if x plus 5 shifts up? What do you think is going to take place when we have x minus 5? I'll give you about 5 seconds. I think you're going to get the answer to this. You got it. It shifts down. So we have our parent function right here. And now when we do x minus 5, that y-intercept is now below that, which means that our entire line shifts down. It's still the same line. It has the same slope, except it shifts down that y-axis. Okay, so y-intercept is pretty simple. It's pretty basic, as the kids are saying these days, because you're familiar with that. But now let's talk about this piece here. Y equals 3x. So we're forgetting about the x plus 5. We're forgetting about the x minus 5. We're back to our parent function of y equals x. We look right here, though, and we say y equals 3x. Well, what does that 3 represent? Hopefully that was enough wait time for you to think in your head. That 3 represents our slope. You know that a slope of 3 means you have to go up 3 over 1. So you rise 3, you run 1. So that is going to be a steeper graph. And it looks like this. Now there's a name for this. This steeper graph is called a vertical stretch. So think about it like that. Vertical means up and down, right? We're basically taking the ends of this line from our parent function and we are stretching it up and down. And when we do that, it gets closer and closer to vertical. We're stretching it towards that vertical line. So that's what happens when you have this slope of 3, or a slope essentially that is greater than 1. Okay, so a slope of 2 would do the same thing. It would be a vertical stretch. A slope of 18 would also be a vertical stretch. But now, if we have a vertical stretch when our slope is greater than 1, what happens when our slope is less than 1? Now we have this 1 over 3. So we have a part of a whole, right? We have a fraction. 1 over 3 means that my rise is only 1, and my run is now 3. Well, before we had a vertical stretch, we were pulling it further and further north and south, or up and down. Well, when that slope is less than 1, we have what's called a vertical compression. So now, if you think about the word compression, right? Compression is like when you push things together, when you want to make something, I don't know, I'm just rambling at this point, I guess, but a compression is when you push things together. Well, that vertical compression, now you'll see, no longer are we stretching it to be closer to a vertical line. We're compressing it to be closer to a horizontal line. We're pushing it down, we're pushing it together, those ends of that line. So a vertical compression happens anytime that slope is less than 1. So we use the example of 1 over 3. It could be 1 over 8. It could be 1 over 2. It could be 1 over 14. It could be 3 over 5. As long as it's less than 1, you're going to have a vertical compression. All right, well, now I want to look at the last piece. The last piece here says y equals negative x. Well, does this affect the y-intercept? Is there a plus or a minus behind the x? Is there a b? There's not, right? So it doesn't affect the y-intercept. Does it affect the slope? Well, there's no number before the x, but if you see that we have a negative before the x, there is technically a slope there. That slope just happens to be 1. But when we put the negative there, it's actually a negative 1. So what does that look like on the graph? Bang, bang, boom, right here. This now is our negative slope. Before we had a positive slope. Now we have a negative slope of 1. We call this a reflection. You see how it's symmetrical right down the center here? That's because we reflected it over the y-axis. So when we have a negative of any kind, you are going to have what we call a reflection. And I'm going to show you real quick. What if we have a negative, let's say 5, oh, that was a 4. Pretend I said 4. A negative 4. See, it's still a negative slope, and it's still considered a reflection. Anytime there's a negative, we have a reflection. So let me get that back out of there because this is a prettier picture. All right, so now let's put it all together. We have ourselves a negative, which means reflection. We have a 1/3, which means a vertical compression. And then we have this plus 5 in behind, which means that we have a shift up of 5 units. So what does this look like on the graph, you ask? Right there. Notice we have ourselves now that negative slope, which is represented by our reflection. We have the fact that it's a little flatter, it's a little closer to horizontal because we have ourselves a vertical compression. We're compressing it to be more and more flat. And that's what this 1/3 is telling us. And then notice it crosses the y-axis right here at positive 5. And what's telling us that? Well, that plus 5 right here, of course. So you can put all of these different transformations together, and you can get all sorts of different lines based off of those 5 basic transformations. And I know what you're thinking. How am I supposed to remember all of that? Don't you just have a slide of notes? Why are you just rambling and telling us all of these things that we're not going to remember? Well, don't you worry. I thought of that as well. So now you're looking at the examples that we just went through and how it looks as an equation or as that formula of y equals mx plus b. So right down here, that negative tells us it's a reflection. When that 3 is there, that number that's greater than 1, vertical stretch. When we have a plus 5, well, we shift it up, of course. And then looking over here, when we have a 1/3 or any kind of fraction that is less than 1 as our slope, we have a vertical compression. And this time when we have this negative 5 as our b or as our y-intercept, well, then we are shifting down. So if you want to make sure that you understand this right here, you can do all of the magical things I just showed you on Desmos right here. Okay? But this is the important piece. Understanding this will allow you to do well when you get to your quizzes, when you get to your tests as it relates to linear transformations.